Buenos dias to everybody. I immediately switched to English, and I apologize for this, but no hablo español. And I will show a brief presentation about the reuse and recycling of secondary raw materials and wastes in building, with some case studies that we developed in Italy along the 2 last years. And this presentation is a sort of deepening and a step back if compared with the presentation that Christina has already showed you, because as laboratory, as a research institution, we work on materials, development, innovation and system. Very few words to introduce our laboratory, just to give you an idea what is our job, our daily job. Certimac is a public-private laboratory founded and held by the 2 main Italian research agencies, ENEA and CNR. And if we take a screenshot of our lab, we can distinguish between 2 main areas of intervention. The first one is devoted to services for characterization and certification of building materials and systems. And the second one is related to the development and innovation into materials and components, devoted to the market and starting from the company needs. As anticipated by Hamie, we work at European level in several technical committees to develop new technical standards and in several funded projects to develop new materials and systems. But I want to go quickly to my presentation, starting from this issue. Waste and recycling at a glance. As you probably know, according to the waste management hierarchy, landfilling is the least preferable option and should be limited to the necessary minimum. So, at this regard, there is a European directive with the purpose to prevent or to reduce as far as possible this process in order to foster a sustainable process, in order to foster a more environmentally friendly future. And for this reason, these data are reported according to the Eurostat source. They show the million of tons, sorry, because the resolution is not so high, but in this column there are the million of tons of waste is produced in each country, and also on the right side of this column, the kilogram per inhabitant produced in each sector, and by economic activities are splitted the waste generated in this graph, and this one is the hugest piece related to construction sector. This is a very synthetic image that give you an idea in brief of the situation right now. And which is the answer? The answer is sustainability. But what does it mean, sustainability, for us at lab level, at research level? In construction, sustainability starts as a strategic junction between the beginning and the end of life in order to convert a waste into a secondary raw materials. And to do that, it's important, in my experience, that we have to put together the knowledge triangle, and Certimac works at the base of this triangle for what concerns the innovation and the research, in strictly contact with the companies and with the factories. So, put into practice this concept, what does it mean? What does it mean? It means that waste could be really a potential answer to a need, because any kind of solid or semi-solid materials originating from some productive process can potentially integrate it into a new industrial process or product in order to constitute to produce a new materials or to give a new life to a material itself. For which reasons? To complete, to improve the mixed design, to increase specified properties, or to reduce secondary undesirable effects, to lighten or strengthen the finished products, and of course to reduce the economic and environmental cost of the waste management. But it's close to impossible to define the ideal waste and to a prioristically define its employability in absolute terms. We need to consider 6 main elements that contribute to the overall complexity of the issue. We need to analyze the chemical composition of the waste, the broad compositional spectrum along the productive year, the different effects of the same waste added to different formula or admixture, the condition for the waste employability, the classification of the waste at European level, and of course the availability of the waste. These 6 variables are crucial to identify the feasibility and the application of the waste. So in synthesis, we want to reduce the environmental and economic cost of waste management. We want to optimize some properties, and we want to reduce the environmental impact. These are the essential requirements to do that, availability and compatibility, and the answer to do that at industrial level, at research level, is industrial symbiosis. A very interesting process that could put together the needs to manage a waste for an industry of a specific value chain with another interest of another supply chain, another industrial field to catch primary raw materials in a sustainable way. Okay, and I will show you now 3 different fields of application, 3 different case study presented, I need to premise, in a very schematic and synthetic way, not with the main aim to deepen in the technical or scientific issues, but to give you some inputs and to give you some information and about the process, about the approach that we implement every day. Okay? The first one is related to innovative masonry elements. In this kind of application, the target was to develop lightweight cementitious masonry blocks, and we started producing them by expanded perlite, blast slag furnace. This is a byproduct of our iron production. That is very interesting because it has a reactive effect as a binder, similarly to cement, and fly ashes produced by thermoelectrical central in Italy. And this use give us the opportunity to reduce the cement content of about 50%. And as you probably know, I'm sure that you know, the cement industry is one of the most heavy in terms of energy and environmental effect impact on the whole construction field. And starting from that, we try to optimize and engineering a components in this manner. First of all, as I mentioned before, we reducted the cement, we added secondary raw materials in order to develop a new admixture. After that, we engineered, we developed a new block, a new masonry through finite element modeling and experimental campaign in order to validate a product for the market, of course, according to the European technical standards. So the manufacturer in this case will have at the end of the process a marketable product according to the European standards. A second interesting application is related to flooring system. In this case, we work on innovative way of using ceramic waste in forms of powder, using to obtain a uniform and monolithic appearance. In this case, this product is produced with the 80% of recycled ceramic in form of powder and to 20% of binder. And of course, this is the final shape of the product. It's interesting because it adapts itself to any shape and dimensions. It's cost effective in terms of installation and in terms of absence of any scraps, and allows casting with reduced thickness. So we have a very high content of recycled materials. We have a cold processing that minimizes the energy consumption and 0 VOC emissions. This is the interesting side. Another thing is that we made some experimental tests regarding the thermomechanical properties, and this thin layer ensure a very outstanding adhesion properties. Consider that a normal ceramic tiles glued with a cementitious adhesive as a load, a failure load, about 1 Newton per square millimeter, and we obtained 4.4 Newton per millimeters. And after that, we enjoy ourselves to make some modeling, some simulation about the application of this layer in a radiant heating system, and this is the difference in terms of result between the performance of the thin layer with the traditional ceramics and other different kind of typical wood. The last one is not a single case study, but multiple case study in the field of mortars, plasters, and screeds. This is the typology of the materials that I will show you. Also in this case, the main aim of the presentation is to share with you the approach and the methodology that we implement. And in this case, this is an innovative way to develop sustainable materials, replacing aggregates and binder and cement in 3 different steps. The first one is related to an assessment on waste in order to verify the previous 6 variables that I mentioned before in the presentation. The second one is a feasibility study in order to evaluate the potential of applicability in a real admixture at lab level, and at the end, the experimental validation and engineering of the materials and the components, testing it according to the European technical standards. And some case studies about it. The first one is a mortar or screed, it depends on the performance, in which we replaced the 50% in weight of the aggregates with porcelain polishing residue, considering that our laboratory is situated there in Emilia-Romagna region, in the north of Italy, and in the same region we have the largest industrial district in the world for porcelain stoneware production. So this kind of waste is very, very, very popular in our region. And also, in our region there is also a regional maritime district devoted to mussel breeding, and we use the ground clamshell pre-treated in a thermal way to replace the aggregates with this kind of waste. So in this manner, we were able to substitute the 100% of the aggregates and to reduce the 30% of the cement used into the admixture due to the pozzolanic effect of the ceramic powder. Pozzolanic effect is an effect that supports the mechanical strength of the final component according to a chemical process. And after that, at the end of the process, we obtained two different versions of the product. One aerated, lightweight, and one as it is, okay, a traditional mortar or screed, in which the percentage of recycled materials is over the 80%, and we obtain all these characteristics according to the European standards. Potentially, we are ready to go to the market, and we are collaborating with some of our customers to do that. Another, an alternative to the previous one is this product in which we have PPR, porcelain polishing residue, but also not clamshell, but ground tires in 3 different granulometries. This is a byproduct of the automotive sector, and it was very interesting in terms of mechanical performance of the mortar due to the high flexibility, okay, the high elastic modulus of these secondary raw materials. And also in this specific case, we obtained a final product with a recycled percentage above the 70% and with very interesting performances in terms of thermohygrometric and mechanical parameters. And in conclusion, starting from the beginning of my presentation, of course, as you know, lead filling is a very, very, very critical issue at the moment to be managed. And building industry on its side try to implement green policies and green marketing, and these policies require even more sustainable and cost-effective solution for the market. And of course, according to my experience, to our experience, industrial symbiosis is one of the answers toward a more sustainable use of natural resources. Thank you for your attention.